Electrical metallic tubing, or EMT, can be used outdoors under specific National Electrical Code, or NEC, guidelines. Firstly, the EMT needs to be weatherproofed. This means the EMT must have a finish that protects it from rust and deterioration. Galvanized EMT is a common choice for outdoor use because of its protective coating. Secondly, use threaded connections and sealing fittings designed to prevent moisture from entering the conduit system. Moisture ingress can cause corrosion and compromise the electrical system's integrity. Thirdly, the EMT must be properly supported to withstand wind, ice, and other environmental factors. Proper support prevents mechanical damage and ensures the conduit remains securely in place. When grounding EMT, the goal is to provide a safe path for electrical fault currents, protecting people and equipment. Firstly, establish a grounding point. This involves driving a ground rod into the earth near the exterior wall where the EMT will be installed. The ground rod provides a direct connection to the earth. Secondly, connect a ground wire, typically a bare copper wire, to the ground rod. This wire will run along the EMT conduit, providing a continuous grounding path. Thirdly, at each connection point such as couplings, vents, and junction boxes, secure the ground wire to the EMT. Use grounding bushings or clamps specifically designed for this purpose. These fittings ensure a low impedance connection between the ground wire and the EMT. Fourthly, terminate the ground wire at the service panel or grounding bar inside the building. This connects the EMT grounding system to the main grounding system of the electrical installation. While polyvinyl chloride, or PVC, conduit may be vulnerable to physical damage, it can still be a viable option if installed correctly and protected. Consider encasing PVC conduit in a metal raceway or using a conduit cover to shield it from damage. Galvanized EMT can rust over time, especially in harsh environments. For added protection, consider using stainless steel EMT, which offers superior corrosion resistance, or applying a paint-on corrosion-resistant coating to galvanized EMT. Always consult local electrical codes and regulations before starting any electrical work. Local codes may have specific requirements or restrictions on the use of EMT outdoors. It's crucial to adhere to these regulations to ensure a safe and compliant installation. In summary, using EMT outdoors requires careful attention to weatherproofing, secure connections, proper support, and thorough grounding. By following these guidelines and consulting local codes, you can safely and effectively use EMT for outdoor electrical installations. Consider the longevity of the installation. While galvanized EMT is suitable, stainless steel or coated EMT may offer better long-term protection against corrosion in harsh environments. Choose fittings that are rated for outdoor use and are compatible with the size and type of EMT being used. Use appropriate tools for cutting, bending, and threading EMT to ensure proper connections and a professional finish. When installing EMT, make sure to maintain proper clearances from other structures and utilities. This prevents interference and ensures safe access for maintenance and repairs. Periodically inspect outdoor EMT installations for signs of corrosion, damage, or loose connections. Address any issues promptly to prevent electrical hazards and maintain the integrity of the system. Keep detailed records of the EMT installation, including materials used, grounding methods, and inspection dates. This documentation can be valuable for future maintenance and troubleshooting. Consider the aesthetic impact of the EMT installation. While functionality is paramount, strive to create a neat and unobtrusive installation that blends in with the surroundings. If running EMT across long distances, consider using expansion fittings to accommodate thermal expansion and contraction. This prevents stress on the conduit and connections. When transitioning from EMT to another wiring method, such as cable, use appropriate transition fittings to ensure a secure and weatherproof connection. When working with electricity, always prioritize safety. De-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. Remember that proper grounding is essential for electrical safety. Ensure that the grounding system is properly installed and tested to provide a low impedance path for fault currents. If you are unsure about any aspect of the EMT installation, consult with a qualified electrician. They can provide expert guidance and ensure that the work is done safely and in accordance with local codes. Understanding the NEC guidelines for using EMT outdoors involves several key sections that address specific requirements. Section 300.3, for example, covers the suitability of raceways for different environments. It emphasizes that raceways, including EMT, must be resistant to moisture and other conditions prevalent in the installation environment. This is why galvanization or other protective coatings are crucial for outdoor EMT installations. Section 314.40 addresses the support of raceways. It specifies that raceways must be securely fastened in place to prevent movement and strain. This is particularly important for outdoor EMT, where wind, ice, and other factors can exert significant force on the conduit system. The supports must be designed to withstand these forces and maintain the integrity of the installation. Section 250 contains the requirements for grounding and bonding. It emphasizes the importance of establishing a low-impedance ground fault current path to facilitate the operation of overcurrent devices such as circuit breakers and fuses. Proper grounding of EMT involves connecting the conduit to a grounding electrode system and ensuring that all components are bonded together to create a continuous grounding path. Section 300.5 covers underground installations. While the question focuses on the EMT installed on exterior walls, it is important to note that EMT is generally not permitted for direct burial. If a portion of the conduit system is underground, it must be enclosed in a raceway approved for direct burial, such as rigid metal conduit, or RMC, or PVC conduit. Section 358 specifically addresses electrical metallic tubing. It outlines the permitted uses and restrictions for EMT, including the types of fittings that can be used and the methods of support. It also references other sections of the NEC that contain requirements for grounding and bonding. When selecting fittings for outdoor EMT installations, it is important to choose those that are listed for wet locations. These fittings are designed to prevent moisture from entering the conduit system and causing corrosion or electrical faults. Some common types of fittings used with EMT include compression connectors, set screw connectors, and threaded connectors. Compression connectors provide a watertight seal and are suitable for use in wet locations. Set screw connectors are a more economical option, but may not provide as tight of a seal. Threaded connectors are typically used with threaded EMT and provide a secure and watertight connection. In addition to selecting the right fittings, it is also important to use the proper installation techniques. When making connections, be sure to tighten the fittings securely to ensure a good electrical connection and prevent moisture from entering the conduit. Use a torque wrench to tighten the fittings to the manufacturer's specifications. When supporting EMT, use straps or clamps that are designed for use with EMT. These supports should be spaced according to the NEC requirements, typically every 10 feet for horizontal runs and every 3 feet for vertical runs. Be sure to use corrosion-resistant hardware when installing the supports to prevent them from rusting over time. When running EMT across expansion joints or other areas where movement is expected, use expansion fittings to accommodate the movement. These fittings allow the conduit to expand and contract without putting stress on the connections. Expansion fittings should be installed according to the manufacturer's instructions. When terminating EMT at a junction box or other enclosure, use a bonding bushing to ensure a good electrical connection between the conduit and the enclosure. Bonding bushings are typically made of metal and have a sharp edge that bites into the metal of the enclosure, creating a low impedance connection. Always inspect EMT installations regularly to identify any signs of corrosion, damage, or loose connections. Address any issues promptly to prevent electrical hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricians have the training and experience necessary to install EMT safely and in accordance with the NEC requirements. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. You can purchase a copy of the NEC from the National Fire Protection Association or view it online at nfpa.org. In addition to the NEC, there may be local electrical codes that apply to your installation. Check with your local building department to determine if there are any additional requirements. When planning an outdoor EMT installation, consider the environmental conditions that the conduit will be exposed to. If the conduit will be exposed to harsh chemicals or corrosive materials, you may need to use a special type of EMT that is designed to resist these substances. If the conduit will be exposed to extreme temperatures, you may need to use expansion fittings to accommodate the thermal expansion and contraction of the conduit. The size of the EMT will depend on the number and size of the conductors that will be installed in the conduit. Consult the NEC to determine the appropriate size of conduit for your application. When pulling conductors through EMT, use a pulling lubricant to reduce friction and prevent damage to the conductors. Do not exceed the maximum fill capacity of the conduit, as this can make it difficult to pull the conductors and can damage the insulation. After installing the EMT, test the grounding system to ensure that it is working properly. Use a ground resistance tester to measure the resistance of the grounding system. The resistance should be low enough to provide a safe path for fault currents. Keep a record of the EMT installation, including the date of installation, the materials used, and the results of the grounding test. This record will be helpful for future maintenance and troubleshooting. Remember that safety is always the top priority when working with electricity. If you are not sure how to do something safely, ask for help from a qualified electrician. By following these guidelines, you can safely and effectively use EMT for outdoor electrical installations.